Good morning, dear students. So, first of all, I welcome you all for the course on fluid mechanics and thermal engineering. So, we'll be seeing about the first law of thermodynamics in this particular lecture. So, let me start with an explanation. Now, you all very well know that the law of conservation of energy, it states that energy can be neither created nor destroyed. It can be transformed from one form to another. So, this is known as law of conservation of energy. Now, what do you infer from this particular law? This means that the total energy, it always remains constant. The total energy always remains constant. It can be only transformed from one form to another. It can be transformed only from one form to another. This law tells that the total amount of energy in a closed system remains constant. This is the foundation for physics, and this law enables us to calculate the behavior of all the physical systems, because most of the engineering systems, they work on the principle of conservation of energy. They transform one form of energy to another form. For example, if you take an air compressor, it receives energy in the form of mechanical work and converts that energy into pressure energy, converts this energy into pressure energy. Similarly, if you take another system like a turbine, which receives energy in the form of pressure energy in the form of steam and converts it into productive work. So likewise, there is a transfer of energy from one form to another, but the total energy of any system, it remains constant. So this is the significance of the first law. So now you take any human body. Human beings, like all other living things, consume energy in the form of food and convert this energy into thermal energy, mechanical energy, and chemical energy. And these form of energy are used to maintain the body functions. So to contract one muscle, numerous processes occur, including mitochondrial energy production, glucose release, the transfer of mechanical energy from acetone to myosin, and so on. Similarly, during breathing, heat energy from the blood and air is exchanged in the respiratory system, demonstrating the importance of thermal energy transfer in the human body. So you can see even in human body, there are a lot of energy transformations taking place. But the total energy remains constant. That is the energy what we get from food. So this energy is converted into various forms for performing the various functions of the body by the particular parts. So now let me go on to analyze a case study, the innovative bio-waste solution. What is the case study here? It implies. So the challenge in this, a general hospital is generating a large amount of biomedical waste, and conventional disposal methods are neither cost effective nor economic. So for this is the case, and what the solution that was opted by the engineering team was, hospital's engineering team decided to develop and deploy an innovative waste treatment system that uses biodigesters based on the principle of first law of thermodynamics. That is, the total amount of energy present in a system remains constant. So this biodigester works on the principle that all the waste generated, this biomedical waste generated, will be heated, retreated, and it will be utilized for some other useful purpose. So the result of this particular thing is the method has been very successful, eliminating the need for any incineration or other forms of waste disposal. In addition, the biodigesters allows for the required recovery of the valuable resources because this biodigesters used for absorbing the biomedical waste and it can, so the waste particles get digested and it allows the use of this waste for as other valuable resource. So what we have learned in this particular session is the application of first law is relevant to a wide range of fields from engineering and physics to chemistry, biology with many different practical applications. The first law of thermodynamics reminds us that energy can not be created or destroyed, only it can be transformed or transferred. So in a society that values sustainability, this principle is more relevant than ever. And the third point is it's a science of the future. The thermodynamics lays down the foundation for modern physics and had a large impact on the scientific thinking in general. The first law is likely to remain central to the scientific and technological development for the foreseeable future. So, in summary, we can tell that the first law of thermodynamics is the essential principle. It helps us to understand the behavior of energy in physical systems. It has wide range of applications and implications from engines that power our vehicles to the very formation of stars in the universe. So, by appreciating the significance of this law, we'll gain a deeper understanding of the world around us and we can make key decisions on how to effectively utilize energy for the betterment of our society. Thank you.